We'll practice finding the charge on an oil drop in a Millikan-style experiment. Here's the problem. In a Millikan-style experiment, an oil drop of mass 3.2 times 10 to the minus 15 kilograms is held motionless between horizontal plates by an electric field of 1.0 times 10 to the 5 newtons per coulomb. The elementary charge E is 1.6 times 10 to the minus 19 coulombs. Part A, find the magnitude of the charge on the drop. Part B, determine the number of excess electrons. First, for a stationary drop, the electric force balances gravity. So we have Q times E equals mg, which means Q equals mg over E. Now substitute the given values. Mass is 3.2 times 10 to the minus 15 kilograms, G is 9.8 meters per second squared, and the electric field is 1.0 times 10 to the 5 newtons per coulomb. Compute the numerator, 3.2 times 10 to the minus 15 times 9.8 equals 3.14 times 10 to the minus 14. Next, find the number of excess electrons, N equals Q divided by E. Computing gives 1.96, which rounds to 2, so the charge is approximately 3.1 times 10 to the minus 19 coulombs, corresponding to 2 excess electrons. Remember, when a charged particle is stationary in an electric field, the electric force equals the gravitational force, allowing you to solve for the charge.